Hi, welcome to our Algebra 1 video series. Here we're talking about a few more examples from 6.5, the exponential equations. So in this section, we're going to rewrite some. Let me erase this. Hello and welcome back to our Algebra 1 video playlist. We're going to take a look at some 6.5 examples, which are exponential equations. In this case, exponential equations with unlike bases. So what I need to do is I need to get these bases to be the same so that I could solve an equation. For example, if I had 3 to the x plus 5 equals 3 to the 10th, if these bases are the same, these 3's, I can ignore those bases and write an equation with just the exponents. But here I don't have the same base. I have 9 and 27. I need to make those the same base by doing a little bit of algebra, a little bit of manipulation to these numbers. So what I need to check first is, does the smaller number taken to some power make the bigger number? So let's check. 9 to the first is 9. 9 to the second is 81. So that's not going to work. I can't get 27 from 9. But is there a smaller number that I can take to some power to make both 9 and 27? And there is. 3 goes into 9, and 3 goes into 27. So let's check. 3 to the first is 3. 3 squared is 9. 3 to the third is 27. So what I can do is I can rewrite 27. And instead of 27, I'm going to write 3 to the third power. But don't forget, I have an x here. I have an exponent that was already there before. I have to make sure that I bring that down. This 9 I can rewrite, instead of 9, I can write this as 3 to the second power. But again, I cannot forget to bring down this exponent, this x minus 2. So notice what we changed here. I changed the 27 into 3 to the third. And I changed the 9 into 3 to the second. But I didn't change anything else. The rest of the equation still stayed there. I still have the exponents of x and x minus 2. All I did was replace 9 with its equivalent of 3 to the second. And I replaced 27 with 3 to the third because those two things mean the same number. Okay, so now that I have this, what I can do is I can simplify some of my exponents. Remember that if I have a power, like x to the third, to another power, like let's say 5, when I see parentheses, I'm not going to do addition or subtraction. I'm not going to do any other operations. If I see parentheses, I'm going to do multiplication to those exponents. Because what does this really say? It says x to the third 5 times. So 1, 2, 3, 4, 5 groups of x to the third. That's what this says right here. It says take 5 groups of x to the third. And if I count these up, I get 15 x's. So anytime you see parentheses, we have to multiply. And when I multiply these two parts together, 3 times x, I get 3 to the 3x. And when I multiply these parts together, I have to distribute this 2 to both parts. And I get 3 to the 2x minus 4. Don't forget this negative 2 also has to get multiplied by 2 to get negative 4. And our entire goal, if we stop and we think about why we started doing all of this, our entire goal was to get the same base. And I have that now. I have 3 as my base for both parts. We can come back and solve this equation later, but I want to look at another example of how we did that. What was that process again? Here I have 2 and 4 for my bases. They are unlike bases, so I can't do anything yet. But I do need to get them in the same base. I need to ask myself, can 2 to some power make 4? And it can. 2 to the second is 4. So instead of 4, let me write that as 2 to the second. But remember, we have this x plus 3. I have to bring down an x plus 3. And this was already 2. So now I have the same base. I have a base of 2 and a base of 2. That's good. So what do we do once we've got our bases the same? I need to start simplifying my exponents. And again, just like before, we said that anytime I see parentheses, that means I need to multiply. So I get 2 to the 2 times x, and then 2 times 3 is 6. My base here is 2. 2 times x is 2x. Two times 1 is 2. Okay. Now we can go ahead and simplify what we have here. I'm going to write my equation of 2x plus 6 equals 2x plus 2. And now I can get my like terms together. I get 6 equals 2. Well, that's kind of strange, because that is a false statement. So anytime you see a false statement in mathematics, what that means is that there's really no solution. There's no way to solve that question to get a true statement, so it must be no solution. Let's go back and check on our other problem that hopefully has a solution. Here again, I can ignore my bases and write 3x equals 2x minus 4. Here I can get my like terms together by subtracting 2x, and I get x equals negative 4 once those reduce. So here I did get a solution, but here I didn't, and that's okay. Our entire process is focusing on getting the same base and then using our exponent properties to simplify to get here. And then we can solve our multi-step equations. That's going to be okay. But really I want to focus on getting here. That's the key. That's where most of our mistakes are made, from the beginning to this step. Once we get to this step, things are pretty smooth sailing past then, for the most part. So we had negative 4. We had no solution here. That was not possible. And now here, this was just simplifying. So the first thing I need to do is I need to distribute, right? I see parentheses, that means I have to distribute. So I get a 2 to the negative fourth power. I get an a to the negative fourth power. I get a b to the negative fourth power. And then I have a to the ninth and b to the sixth. And I'm going to put that all over 1. And now let's do some simplifying here. I see some negative exponents, and I know that negative exponents are not okay. And if those negative exponents are negative in the numerator on the top of the fraction, I can move those to the other side of the fraction to get positive exponents. So here what would happen is I would end up with 2 to the positive fourth, a to the positive fourth, b to the positive fourth on the denominator side, and then a to the ninth and b to the sixth in the numerator. And now let's do some simplification. Looking at our whole numbers, the only whole number I have is 2 to the fourth power. And I can use a calculator, or I can have my multiples of 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the fourth is 16. I should list that better. 2, 4, 8, 16. That would be 16. For the a's, I have more a's in the numerator than I have in the denominator. And I'm going to have to do some subtraction. I see dividing, but I'm not going to divide. I'm going to subtract. So 9 minus 4 is 5, and I have more a's in the numerator. I have 5 more a's in the numerator than I have in the denominator. And for the b's, let me choose a different color. Let's go with, what do I got here? Let's go with this color. I have more b's in the numerator than in the denominator. I see division, so I'm going to subtract 6 minus 4 is 2. And now there are no like terms for me to combine here. So my final answer would have to be a to the fifth, b to the second, over 16.